how do I solve for b? If the b needs to be between 0 and pi over 2, so in other words, a first quadrant angle. Does anybody remember how we solve a question like this? So it's a cosecant on one side of something is equal to the secant on the other. So any suggestions? I can give you a hint. It has a lot to do with cofunctions. And hopefully that hint is enough to sort of point you in the right direction. Right? Is there a way that we can rewrite this so that the cofunctions can help us to solve this? It's an equation, right? We just need a value of b that makes left side equal to the right side. Try to get everything to sine or cos. Well, not sine or cos, because you can actually deal with cosecant and secant, all cosecant or all secant. That's possible, right? So what I would say is, Jeremy, rather than trying to change it to sine or cosine, why don't I remember? Let me remind you of something that we are supposed to know from the cofunctions, that the secant of pi over 2 minus theta is equal to the cosecant of theta. And it goes the same the other way. Are you recording today's lesson? Yes, I am, Emily. I am. Right? And it works the same way as well. The cosecant of pi over 2 minus theta is equal to the secant of theta. That hopefully should look familiar. That's the cofunction. So why am I using pi over 2 minus theta? Why am I not using pi over 2 plus theta? Or 3 pi over 2 plus theta? Or 3 pi over 2 minus theta? Can anybody tell me why I'm using pi over 2 minus theta? All right? Why did I choose that cofunction? Because I could have used one of the other cofunctions that we covered. And by the way, it's not a bad idea for you to go back and look at the cofunction video again. It's there for you whatever day we did it. I don't remember. Plus, it's on the Math Video Library anyway. You can find the cofunction one there, cofunction video there. Does everybody know why I'm using pi over 2 minus theta? Because there are others. Because it has to be less than pi over 2 and above 0, Harish says. Absolutely. This says that I want this thing to be in the first quadrant. I want my b to be somewhere between 0 and... That's a first quadrant angle. So we're using the first quadrant cofunction identities. So here's what I'm going to try to do. I'm going to try to take this one of these sides and turn it into the other thing. So either the cosecant becomes the secant, or the secant becomes the cosecant, right? And Noah, you're right. And Harish, you're right. It's because it's the first quadrant. I just want to acknowledge that you both got it completely right. So is there a preference? No, it doesn't really matter which way you take it, as long as you have it all secant or all cosecant. So what I'm going to do is I'm going to take this version, because it's the second one I wrote, I'm going to take this version and I'm going to use it. The secant of something, this thing being theta, is equal to the cosecant of pi over 2 minus that same angle. So instead of saying the secant of 2b minus pi over 8, I'm going to make that equal to the cosecant of pi over 2 minus this same angle here, which is the 2b minus pi over 8. Okay, that's what this line says, that the secant of this angle, are these identities the same as the sine minus cosine? Replace the sine. Sine minus cosine minus tangent, replace secant. Okay, Jeremy, yes. When you say if are they the same, the cofunctions are sine and cosine, tangent and cotangent, secant and cosecant. Those are the things that are cofunctions of each other, if that's what you mean. Okay, is that what you mean, Jeremy? So sine and cosine are cofunctions of each other, yeah? Correct. It's a co-function. It's a co-function of cosecant. Yes. Yeah. Cosecant. Yeah. Tangent and cotangent. Correct. Yes. That's exactly right. Yes. Yes, that's exactly right. So as long as you're trying to solve an equation where you have two co-functions, you can use the co-function identities. Okay? So let's continue. Let's continue. I'm saying that this secant, the secant of, so this secant that I have here, that I just circled, I can write that secant as the cosecant of pi over 2 minus that same angle, the 2b minus pi over 8, because that's what this line says. The secant of this is equal to the cosecant of pi over 2 minus that same thing, that same theta. So I can actually simplify what's on the right-hand side here. So that's equal to the cosecant of, so pi over 2 minus 2b plus pi over 8. Okay, remember I'm minusing a minus, so it becomes a plus. All right, so let's keep going. So that's equal to the cosecant of, now pi over 2 plus pi over 8. Well, the common denominator here would be 8. So that would be 4 pi plus 1 pi minus 2b, right? So that would be the cosecant of 5 pi over 8 minus 2b. Okay? So what we're saying is that all of this is equal to what we had before. What we had before was a secant of 2b minus pi over 8. That's what I'm pointing to right now. So this is all equal to the secant of 2b minus pi over 8 is equal to the cosecant of this. Well, here's something else we were told, that this secant of 2b is equal to the cosecant of this. So instead of putting the secant of 2b minus pi over 8, I'm going to put what it's equal to. It's equal to this other thing over here, which is a 6b plus pi over 8. So I'm going to replace that with that. So the cosecant of what it says it was equal to, pointing to it there, cosecant 6b plus pi over 8, 6b plus pi over 8. That's what this is equal to. That's what that secant is equal to, right? And therefore, that's also equal to the cosecant of 5 pi over 8 minus 2b. So they're all equal to each other, right? Let me go with that again, just one more time. I took the secant of 2b minus pi over 8, and according to what this line says, it's equal to the cosecant of pi over 2 minus that same angle that I was taking the secant of, which is a 2b minus pi over 8. I did some math on it here, right? I brought those two together, the pi over 2 and the pi over 8, and I'm getting 5 pi over 8. So 5 pi over 8 minus 2b is what this is the cosecant of. So that's what the secant is equal to. The secant of this is equal to the cosecant of that. Then I can replace the secant of 2b minus pi over 8 with this, the cosecant of 6b plus pi over 8, which I've just done, and set that equal to what this other side is. So what do you think I'm going to do next? Let me go over to the class and ask you what you think I'm going to do next. All right? Jeremy, go ahead. Because they're both cosecants, correct. So I can now say that because I know I couldn't do this before because one side was secant and one side was cosecant. But now that we have both of them being cosecant, I can now say, okay, that means that 6b plus pi over 8 is equal to 5 pi over 8 minus 2b. Okay? I know all I need to do is solve for b. That was the whole point in the first place. All I need to do is solve for b. So I'm thinking, okay, why don't I bring that 2b on this side, so that would be 8b, and bring that pi over 8 on the other side is equal to 5 pi over 8 minus pi over 8. And we actually did the opposite of that before. We added, well, let's just go through with it. So that's equal to 5 minus 1, which is 4. So 4 pi over 8, in other words. Let me erase that. So that's 4 pi over 8. And 8b is equal to that. Of course, that's equal to pi over 2. Okay, how did you get the 6b again? How did I get the 6b? Oh, the question told us that. Let me take you back. Take you back to the top. We were told that this secant of 2b minus pi over 8, Joel, and that divided by the Joel, thanks for the question, was equal to the cosecant of 6b plus pi over 8. Okay? So when we took that secant, well, we took the secant that we had, the secant of 2b minus pi over 8 right there, made it into a cosecant, all right? And that was what this was. It worked out to be this cosecant down here. All right. So so let me see now. So double checking for the cofunction identities. Cotangent replaces tangent, cosecant. No, cosecant. No, it's not cosecant and sine. It's cosecant and secant. So it's not. So it's not, Jeremy. It's not. All right. Mm-hmm. 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 Correct. Mm-hmm. If I think I'm understanding you right, then yes. Just remember, just think of what the pairs are. The things that are correlated are sine and cosine, tangent and cotangent, secant and cosecant. Those are the ones that tend to interchange once you do the pi over 2 minus. Okay? It is. It is. If you go to the Math Video Library on the Unit 4, because we did this in Unit 4, you'll see one of the videos there that's referred to as the cofunction identities, and it's by me. Okay? So you might want to take a look at that. You're welcome. All right. So let me just make sure I answered Joel's question. So Joel, you're okay now? How did I get the 6b? Does that make sense to you? You got it. Okay. So all I need to do now is just finish solving this equation down here. 8 by 8 pi, sorry, 8b is equal to pi over 2. So that means that b is equal to pi over 2 multiplied by 1 over 8. Same thing as dividing by 8. All right, you can divide by 8 by multiplying by 1 over 8, and that's equal to pi over 16. So there's your value of b, right? And of course, as usual, excuse me, you can always test that out by putting that back into the equation. The cosecant of 6 times the pi over 16 that we just got, plus the pi over 8, should be equal to the secant of the 2 times the pi over 16 minus pi over 8. Again, you can try that out on your own time. Why do we multiply by 1 over 8, Kayla? Good question. Good question. Let me answer that. Let me answer that. I'm just going to come down here. If I had that 5x is equal to 30, how would you figure out what x is? Kayla, how do you figure out what x is? Tell me what you do. How do you figure out x? Divide both sides by 5? Okay. How about we try this instead? Multiply by the reciprocal of 5, which is 1 over 5. So 30 times 1 over 5. Because the reciprocal of 5 is 1 over 5, right? So multiplying by 1 over 5 should do the same thing as dividing by 5. And this question up here asked us to, that 8b was equal to pi over 2. So I said, okay, I need to divide by 8. Another way to divide by 8 is to multiply by 1 over 8. Does that make sense now, Kayla? Why we multiply by 1 over 8? Because it's the same thing as dividing by 8. Okay, and thank you for the question. I appreciate that very much. So, of course, in this case, the answer is 6. But in this case, the answer was pi over 16. Okay, so I'm going to move on to the next question, but I hope that people followed that, and it will be on a video, so you can certainly take your time. And again, if you need to see me in the 3 o'clock time slot, I'll be there. All right, let's move along. Another question that we could look at is certainly one like what you did for homework last night, which I hope everybody did. The height in meters relative to the surface of water of a particular paddle on a wheel of a paddle boat is a function of time, etc., etc. And it gives you this. From 0 to 60 seconds, right? They measure the height of the paddle, and if it's positive, it just means it's above the water, and if it is negative, it means it's below the water. That's all the positive and negative means, right? The height in meters relative to the surface of the water. So if you're at 0, it means you're at the surface of the water, right? Positive, you're above. Negative, you're below. That's all that means. Okay, so if you had to do an equation for this, use the data to write the equation of a sinusoidal function. Let's go through that process right now, which is hopefully what you did for homework last night. All right, starts off at 0 at minus 1.2, and then it goes at some point in time it gets back down to 1.2 when you get to 60 again. Let's see if we can come up with the A. It's exactly what we did yesterday. Let's see if we can come up with the A. Let's see if we can come up with all the things we talked about yesterday. The A equals, the C equals, the period is whatever, and therefore the K is whatever, and then what is the phase shift? Okay, so who can tell me what the A is in this particular case? What's the A of this function? And remind me how we get that A, right? So what is it and how do we get it? For yesterday's homework, were we supposed to just draw the graph or do the questions? No, you just had to draw the graph, Jeremiah, and put the equations in and try to make sure that the equations did a pretty good job of following the scatter plot. All right, and he gave me that link, and that was all I needed from you. All right, so I'm getting from Harish 1.395, and Nicholas agrees with that. I'm going to write that down. And hopefully everybody understands where that came from. 1.99. Whoa, I'm not sure about that, Kayla. Let's go through the process again. So high in this case is, excuse me, the high in this case, of course, is the 1.39, if we can agree with that. I didn't like the A, B, or C. Thanks for the clarification. Okay, all right. You got 1.39. There was 1.39. So yeah, okay. All right. So just a small error on your part. So 1.395 sounds good to you now? Does that sound okay to you then, everybody else? Yeah? All right. So how about the C? What value of C makes sense for everybody in the room? Give me a value of C, please. Give me a value of C. What is the C in this case? Go ahead with your calculators, please. Minus 0.005, I'm hearing. Can we all concur with that? Access says yes. Excellent. Again, if you put this on a graph, it may not be that every single point lines up, right? There may be points that are a little bit off, and that's fine. What do you think the period of this function is? What are people thinking is the period of this function? And that's a question that some people ask me when I set this as homework. A lot of people are thinking it's 60. And I'm thinking, okay, if I looked at the high and the low of this function, that's one way to do it, by the way. The low seems to have occurred at minus 1.4, and the high, this is one of the ways to do it, the high occurs at 1.39, and therefore if I measure the high to the low, that's half of the period, and that would be 30, 5 to 35. So I'm going to think that if I just double that, that should give me the full period, which in this case is 60. So absolutely, the period is 60. So if the period is 60, What's my k value in that case? Right? Give me a k value now. So pi over 30. The phase shift, and I remind you, if you're writing, no, it asks you for a sine function, but I would say the easiest way to do it is to write a cosine function and then change it into a sine function. That's my approach. That's what I think is the easiest way to do it. And I think we should do that right now. So give me the phase shift based on a cosine function. I know the question says write a sine function. I get that, and we will. How do we get the period is what you're asking about, Ava? Is that what you're asking about, Ava? Yeah, okay. So one way to get the period, right, is to measure two highs. Well, unfortunately, there's only one high in the function, and that's this high right here. By the way, would you agree with me that that's the high of the function, right? Would you agree with me on that, Ava? All right. So we have a high, and what is the low of the function? Give me the low of the function. Okay, so there you go. So that's where they are. Now, how far, remember, a period is measured horizontally. So look at your x values, or your t values in this case. How far apart are those x values? Or the t values, sorry, I should say. How far apart are they? No, they're not. They're not 60 apart at all. It's 5 to 35. So it's not 60, right? From the high at 1.39 to the low at negative 1.4, isn't that just 30? You see where that is 30? It's from 5 to 35, right? So that's a half of a cycle, is how I like to look at it. It's a half of a cycle. Because if you go from the high to the low, you haven't completed a cycle. You've only done half of a cycle. So if I took that distance along the x-axis and doubled it, that would be the period, which in this case is 60. So it starts off being 30 for the high to the low, and then I just double that. Does that make sense to you now, Eva? Okay, great. So we're going on, right now we're going with the 60 as a period, and therefore the k is pi over 30. Let's get to the phase shift now. Now let's write the phase shift as if this was a cosine function. We'll get to the sine function later on. So phase shift based on cosine, right? Because it makes a difference, right? And I see some people have put some answers in the chat already. Some people are thinking it's x minus 35. Now I wonder why they're saying that. Well, let's go back up and have a look. Let me erase this stuff here. And I'm looking and I'm thinking, if it's a cosine, where is the high of the function? The high of the function is right here. We talked about that before, right? How far did I have to go to get to that high? I went 35 to the right. So I'm going to put that as x minus 35, right? So my phase shift based on a cosine function is x minus 35. So what I'm going to do is I'm going to start by writing a cosine function. That's not what the question asked for. I want to be clear on that. The question didn't ask for a cosine function. The question asked for a sine function. But we're going to get there. We're going to get there. So here comes my cosine function based on all the stuff we have there. So y equals, well, I guess it shouldn't be y. It should be, what is this? It should be h. I wouldn't take any marks off of that, but just say it. So h equals 1.395 times the cosine of pi over 30 x minus 35 minus 0.005. Okay, that is my cosine function. But now I want to try to make this into a sine function. And I remind you, I need to add a quarter of the period. Remind me what we said the period was again. It's right there on the screen though. It's staring at you and saying, I'm right here, folks. I'm right here. What would be the period of it's 60? Thank you, Kayla. Sorry, could you quickly go through how we got the period again? And the K. Okay. Okay, Isaac, no problem. And I prefer that you do that. All right, so let me pause. And Kayla, you have the right answer, by the way, but just going to pause for a minute so that I can answer Isaac's question. One way to get the period Isaac, and bear in mind that the period, remember, is a horizontal distance. It's how far apart how long does it take you to complete a cycle? Well, it's kind of not obvious because I only have one high in the function at 1.39. I don't have any more highs for me to say this is how far apart the two highs are. So I thought, okay, I have a high and I do have the low. I'll circle them both for you. So here's my low right here. Right? Would you agree that that's the high and the low, Isaac? Would you agree with that? Hello, Isaac. Is Isaac with us? Isaac. So it reaches minus 1. How I went through a full cycle? No, it did not. I'm not saying it went through a full cycle. Oh, you mean the minus 1.2 to the 1.2? It could, but we don't know because that's not either a high nor a low. So I don't want you to use 2 points that are in the same place to try to figure out where the cycle is. That's not a good strategy at all, right? So I'm saying try to find the highest point and the lowest point, see how far apart they are, and then double that distance. Well, they are 5 to 35, which is 30 apart, is what we're saying, Isaac. So that distance is half of the period. So we double it to get the full period, which is the 60. Now, what we did is we just simply put 2 pi over that 60 to get what the k is, which works out to be pi over 30. Okay, so back to this sine equation, because the question asks for a sine equation. All right. To get a sine equation, we add a quarter of the period to the cosine. I asked a question a few minutes ago, and Kayla said that the period was 60. So let's take that 60 and divide it by 4. And by my math, excuse me, that's equal to 15. All right. So what we're going to do is we're going to take the x minus 35. We're going to add 15 to it. So Kayla is ahead of us and says it's x minus 20. So now I'm ready to write my sine function. So h equals 1.395 sine, this time, pi over 30, x minus 20 minus 0.005. On a graph, you couldn't tell the difference between both of these two equations. That sine equation and that cosine equation would overlap each other, right? Would they catch every single point? No, maybe not. I'm not saying that. I'm not saying every single point is going to be on the line, but I am saying that the two models that you come up with would overlap each other, is what I'm saying. Okay, so we've answered that question. Let's go back and see if we can answer some more questions now. What is the diameter of the wheel? Remember, this paddle is on the wheel, right? So let's draw a little circle. And let's put a point there as being the paddle that's on the wheel. So think of it like a circular thing that is going into the water, out of the water, into the water. Let's say the water is that thing there. Okay, don't laugh. It doesn't look like water, but this is protect, use your imagination. So that thing is starting off at some point, going into the water, out of the water. And the question is, well, what's the diameter of the wheel? How are we supposed to get that? How are we supposed to get what the diameter of this wheel is? Can anybody think of what the diameter of the wheel might be? Do we have enough information for that? Yes, Jeremy. Mm-hmm. Mm-hmm. I agree with you completely. So the amplitude would represent the distance from basically across like that, from the high to the low, which goes straight through the center, right? So that would be a diameter. Now, remember the amplitude only goes to the center. And if you want to get the diameter, you have to, so that would be the radius, in other words, is what I'm saying. So if you wanted to get what the diameter was, just simply take the A and double it. No, part C, I think, is too easy for us to spend a lot of time on, right? So what would be the height of the paddle after 97 seconds? Well, 97 seconds is not in the table, but very quickly, how would I figure out how what the height of the paddle is at 97 seconds. So we have the model. Just sub 97 into x. Absolutely. That's easy enough. The part that's going to take us more time is after how many seconds would the paddle reach a height of 1 meter above the surface? Now we have a choice to make. I think I know what choice Noah would make, by the way, but let me just throw it out to the class. Do you want to do this with the cosine function or with the sine function? The question did, I think I saw that coming. I think I saw that coming. Anyway, the sine function yesterday was the one that gave us the first time that this happened, and probably because sine is in the first and second quadrant, whereas cosine is in the first and fourth quadrant. So it forces you to go further if you're going in a positive direction, or if you want to go in a negative direction, you might be able to get to something that you're trying to get to faster. So let's take Noah's advice. Let's go with the sine function. So again, what we're trying to do is figure out where the thing is 1 meter above the surface. And we have a table that can kind of sort of tell us where that might be, right? So I'm looking and I'm going along, it's 1.2 below, minus 1.4, it goes deeper, then it comes back up, then it comes back up a little bit more, then it goes to 0, then it goes to 0.68, then it goes to, I'm thinking it's going to be somewhere between 25 and 30. What do you think? Does that make sense? That's the answer that I am thinking we should get. What do you say, folks? Does that answer make sense? I'm trying to get to 1 meter, and it's below the surface here, and it says 1 meter above the surface. It's below here, below, all of these are below, all of these are below, right? Between 0 and 6.8, that's not going to give us to 1. That's just, we haven't got to 1 yet. But by the time we get to 30 seconds, we're above 1. We're at 1.19. So somewhere between 25 and 30 is what we should expect. So let's see whether our equation is meeting our expectations. So where do I put the 1? Where do I put the 1 in this case? Where do we expect to put the 1, folks? Help me out here. Where does the 1 go? Where does the 1 go? Did I put it in for the x, or the h is equal to 1? Correct. Okay. So 1 is equal to 1.395 sine. We've been told sine is a better choice. Over 30, x minus 20 minus 0.005. So what's the next step? Walk me through that process again. I don't remember how this works again. Help me out, folks. I'm struggling here. Come on, help the teacher out. Where do we go next? What do we do now? I need to solve for x. I'm stuck. Come on, help me out. Oh, is that okay? Thank you, Jeremy. I think I should try that. Let me try that. So add the 0.5 on this side. So it's 1.005, because it's a minus on that side, is equal to 1.395 sine pi over 30 x minus 20. Okay, 1.395. Okay. All right, I'm stuck again. Sorry. I guess I'm struggling here, folks. Help me out. I'm not sure what to do next. Come on, help a teacher out here. What do I do now? Oh, I see. Okay, Nicholas said divide by the 1.395. Okay. All right, that might help. Let me see if that helps me out. So 1.005 divided by the 1.395 is equal to the sine of the pi over 30 x minus 20. Okay, that looks like we're getting closer. But we still don't have x. So what happens now? What happens now? Thank you, Jeremy. Thank you, Nicholas. Inverse sine. Oh, okay. So sine, so what should I make equal to that? Inverse sine of what part, by the way? What do I find the inverse sine of? What am I trying to find the inverse sine of? Of what? Oh, I see. Okay, so I'm going to say the pi over 30 x minus 20, and again, I'm going to call this prime for now, is equal to sine to the minus 1 of the 1.005 over the 1.395. Okay, we might be getting somewhere here. So can I get one of you now to find the sine to the minus 1 of that thing? and tell us what that is. So let's see now, pi over 30, x minus 20, and we'll call this prime for now. Right? Okay, so Joel is giving me 0.804422, approximately. 0.804422. Thank you, Joel. And which quadrant should I be putting that angle into? Which of the quadrants makes sense to you? Which quadrants, because remember, it's going to happen more than once. So which quadrant should I be doing this in? Not just Joel, everybody else. Which quadrants make sense? 1 and 2, Emily and Jeremiah and a bunch of people are saying, Noah, Emily as well, all of you, Axel, are saying 1 and 2. And I completely agree. So I need a 0.80 in this quadrant. Just put 804 here. I need a 0.804 in this one over here. Sorry, 0.804 in this one over here. No, if we're lucky, it'll be the first one here, and we don't have to use this one, but we're not sure. We're not sure. Let's find out. So let's go with the first one as being 0.804, right? The second one here is in the second quadrant, and we have to do something to get the actual angle. So pi over 30, x minus 20 is equal to 0.804. And how do I solve for this again? How do I actually get this answer again? Multiply by 30. Okay, yeah, and what else? Multiply by 30. Yeah, on both sides, good. Not just multiply by 30, but also divide by pi. Okay, so I'm going to put it this way. X minus 20 is equal to 0.804 times 30 over pi. And then I'm going to go ahead and add on the 20, 0.804, 30 over pi, plus 20. Okay, good. Okay, Joe, thank you very much. Thanks for all that help, because I was really kind of not sure where to go with that. But you guys kind of bailed me out there. Thank you. Can you give me what that answer is, please? Let's see if we got it on the first one. And if not, do we go further in a positive direction, or do we start going in a negative direction like we had to do yesterday? That is what we need to figure out. Whoa! 27 point. Whoa. Okay. So the answer I'm getting from you is 27.7. Let's just say 27.7. Now let's see how that compares with what we were thinking. Let's see how that compares with what we were thinking. So we said that it would be somewhere between 25 and 30. Remember we said that earlier on? So do we have to search any further? Do we have to go into the second quadrant to see if we can get another answer? Are we good? What do you think, folks? What's your opinion? Did we get it on the first try? For some reason, my calculator isn't giving me the same answer as you guys forgot. Oh, Noah, are you in radians? Remember we talked about the fact that we need to be in radians for stuff like this? Oh, okay. So let's do it in stages, Noah. Try 67 over 93. What? 67 over 93. Oh, is that the reduced form of that? Is that what that reduces to? Reduce? Okay, all right. I still get the same, Jeremy. Okay. Okay, let's do it in stages then. Let's do it in stages. I'm going to grab my calculator as well because no, I want to make sure that we're both on the same page. I'm going to hit my second function key and then my sign. I'm going to put the 1.005 over the 1.395. And I'm going to get an answer. You're not getting 0.8044 on that? Okay, Kayla. You're not getting that, Noah? The 0.8044, you're not getting that number? No. You're sure you're in radians now? Are you 100% sure? If you put your calculator on the camera, we'd all verify that this was in radians. You're saying no, it's not in radians. Well, that's not good. because that's important. You've got to get it in radians. No. Oh, I'm sure I'm in radians. You know what I think you're doing? What you might be doing? You're not using a bracket. And it's probably finding the sine to the -1 of the, no, because if you're putting one, no, that shouldn't work. You should get an error message. Try restarting your calculator. Yeah. If you want to, Noah, come see me at 3 o'clock and I'm going to ask you to put your thing on it, put your calculator on the camera because I want to see exactly what you're doing. Okay? All right. And make sure you're using sine to the -1, by the way, as you saw Jeremiah put that in the chat there. Okay. So my question is to come back to what we're talking about. I'm just dividing and I'm not. Let's do this. Let's do this. Let's do this. I know. Let's try one more thing. Take the 1.09, sorry, 1.005 and divide it by 1.395. Do that first and press equals. Can you try that for me, please? 1.005 divided by 1.395. When you have an answer, please let me know what it is. Okay, so you're getting 0.7204. Okay, go ahead now and hit the second function key. Now remember, calculators can keep the previous answer. Hit the second function key and your or inverse, or I don't know what it is on yours, shift or whatever it is. All right, and bring back. There's probably an answer key on your calculator to bring back the last result and see what you're getting. So second function. Sorry, I know the mistake. Oh, you did. Okay. All right. Good. 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 As long as you figured it out, we can move on then. So did we get the right answer, folks? We haven't answered that yet. Is it 27.7 making sense to all of us, or should we be looking elsewhere? All right. I think we figured it out. So 27 points. And by the way, what unit should I put for this? Right? What units would make sense for this? No, you're welcome, Noah. What units would make sense for this? Seconds? Well, let's go back and see what the T was. We've been using X. It actually should have been T. The T was measured in seconds. So yeah, this answer should be in seconds. You should have a statement as well, but because of the time that we have, we're just going to put seconds and move on. All right, let's just move on. All right, but you do need a statement for questions like this. All right, next question. Oh, we just did that question. Why is it there again? I don't know. All right. Solving some equations. You can absolutely expect to solve equations tomorrow. Now, the one that I want us to focus on before the end of the class is this one. Right? 2 sine squared x plus cosine of x minus 1 equals 0. By the way, it says give exact answers where possible and 2 decimal place accuracy where needed. So if it is possible to give an exact answer, you should. In fact, you have to get full marks. I think the trick behind C. Okay, you think there's a trick behind C? What do you mean? Tell me, expand on that, Jeremy. What's the trick that you're thinking? Mm-hmm. How? I think that's an excellent idea. One of the Pythagorean, one of the Pythagorean identities is for sine squared. So sine squared x is equal to 1 minus cos squared x. That is one of the Pythagorean identities. You use that quite a bit when you were doing those trig identities. And trig identities will definitely be on the test, by the way. And maybe we'll do a few of them tomorrow. Let's see if we can get this one done right now first, though. So I'm going to make a substitution. Instead of saying 2, I want everything to be in terms of either cos. Okay, Nicholas. All right. It's either cos or in terms of sine. I don't want sine and cos in the same equation. Just like when we're doing that, the cofunction question where we had to have everything in cosecant or everything in secant. I want the same thing to happen here. So I'm going to make a substitution. For that 2 sine squared x, I'm going to say 2 times 1 minus cos squared x plus cos x minus 1 equals 0. So I took the sine squared out and put 1 minus cos squared x in its place because they're identities. They're the same thing. So what do you think I'm going to do next? All right, let me throw that out to the class now. What do you think I'm going to do next? Or what should I do next? I guess I could say I'm stuck again, right? I need you guys to bail me out. What do I do now? What do I do now, folks? 2 times 1 minus cos squared plus cos, okay. Product law? What do you mean by product law? What does that mean? Magic X first? Well, we might get to that, but we're not there yet. We're not there yet. Any ideas? Not just Jeremy, but anybody else? Anybody have any ideas? Divide by 2? No. How about if I just use a distributive property and multiply that 2 into this bracket? Can we do that? Is that possible? Let's try that. So 2 times 1 is 2 minus 2 cos squared x plus cos x minus 1 equals 0. All right, so I just multiplied out that 2. So why don't we now maybe rearrange this a little bit? Put the minus 2 cos squared x first, then plus the cos x. Then that 2 and that minus 1 should be plus 1 equals 0. Now, I don't like to try to solve, this is like a quadratic, by the way. I don't like to try to solve a quadratic when the lead coefficient is negative. So you know what I do? If it's all equal to 0 already, I just multiply both sides by minus 1, right? So this side is going to change sign. It's going to become 2 cos squared x. It's going to become minus cos x. It's going to become minus 1 equals. The other side is still going to be 0 because multiplying the right-hand side by minus 1 or multiplying by anything is still 0. I just like it this way better. Because now we can talk about magic x. Now we can talk about factoring this because it's a quadratic. So here we go. In the minutes that we have left, this is minus 2 at the top. This is minus 1 down here. Give me those two numbers quickly, folks. Two numbers multiplied to give you minus 2, added to give you 1. What are the two numbers I'm looking for? Multiply to give you minus 2, add up to give you minus 1. Come on, there are two numbers that do that. What are those two numbers? Nobody knows what the two numbers are? Nobody can help me out here. Minus 2 and 1. Thank you very much. All right? Then divide both of these numbers by 2. This one reduces down to minus 1 over 1. This one stays at that. So I'm going to say this is 2 cos x plus 1. And the other one is going to be cos x minus 1. That's what the 1 over 1. This is reducing down. That's what that is. All right. Thank you, Sharisa. And thank you, Rachel. Okay. So now we can use this zero product law at this point. That means that 2 cos x is equal to minus 1 and cos x is equal to 1. All right, let's see if we can rush through this. I want to try to finish this question. That means that the cos of x is equal to minus a half, that x prime is equal to the cosine of positive a half. And when I say I need your help this time, I really do. I was kind of just clowning around before, but I don't know which angle gives us a half, so I will need your help with that. And we're going to see if we can figure out the other side of this in a minute. What is it for the cosine? Oh, cosine to the minus 1, sorry. Cosine to the minus 1 of a half. Pi over 3, thank you very much. So pi over 3. And what quadrants, draw a quick thing here, what quadrants does my pi over 3 need to be in? Right? Remember, the cosine originally was negative. So what quadrant should I put that in? Not so sure about 1 and the 4. I don't think so. Remember, it needs to be negative. Right? Originally, it was the cosine of x is equal to minus a half. Okay, Nicholas. So I'm going to go with 2 and 3. Good. So a pi over 3 here, and a pi over 3 here. So what do those angles actually work out to be? Very quickly now, we really are up against the clock here. If I'm looking for an angle in the second quadrant, I'm looking for an angle in the third quadrant. What are those two angles? Thank you, Haxa, by the way. What are those two angles? A pi over 3 away in quadrant 2, a pi over 3 away. Thank you, Rady. So 2 pi over 3 and 4 pi over 3. Those are those two. Let's quickly go to the other side, see if we can get this done. Where is cosine equal to 1? Right? Does anybody know? I don't even need to use prime or anything. Tell me where oh, by the way, in the between 0 and 2 pi, because that's what the domain is. Between 0 and 2 pi, give me some angles that will give us a cosine of 1. Think of the cosine function. And I'll give you a clue. There are two places. Okay, so one is at 0. And where's the other one? I know Harish meant 2 pi. I know that's what he meant. All right, Harish, he meant 2 pi, right? Of course you did. All right, so very quickly, those are all my answers there. All right, so x is equal to 2 pi over 3, 4 pi over 3, 0, and 2 pi. So those are all the answers I have within the, where am I now? Between 0 and 2 pi. Okay, right there.